Hi everyone, it's time for us to get comfortable with our graphing calculator. Just in case you haven't been playing with it, uh, y equals, on button, equals button called enter. We're going to be using a lot of these buttons that you haven't maybe used before. And certainly today, I want to do the graphing calculator training lab. Um, Yeah, so I'm not sure how many of you are comfortable with graphing calculator. You will definitely require a graphing calculator this year. TI-83 or TI-84 is recommended. You can actually get them pretty cheap on eBay. I don't think you need a TI-89. I don't think you need an Inspire. And I definitely don't think you need a Casio because I can't help you with any of those other calculators. You'll be doing a lot of YouTube videos to figure things out if you get one of those. I recommend a TI-83 or a TI-84. Okay, so with your graphing calculator, let's go through this training lab. Training lab. And this will give me the opportunity to see if I made some typos. So during the lab, you will learn to graph a function to choose a good viewing window. You will find maximum and minimum values as well as zeros of a function. Zeros are x-intercepts. You will also be able to find when a function is equal to a certain value and what the value of a function is at a certain point. You will explore y equals, zoom, graph, calc, and table buttons in this lab. Okay, exercise number 1. Uh, and I recommend actually getting this document out of our Office 365 Teams and filling it in and making notes on it as we go. So let's start by graphing the function y equals 2x squared minus 2x plus 12. To do this, turn the calculator on, and then press the y equals button. Now, I notice I have some stuff here, so I'm just going to press clear and get rid of those. Um, so 2, and then the x squared button, I can use this, or I can say x raised to the second power minus 2x plus 12. Okay, so I've typed that in. I seem to have put it in y2. Most people put that in y1. It doesn't really matter where you put it. Um, Okay, it's important to find a good viewing window to ensure that you have captured the important features of the graph, such as x-intercepts, y-intercepts, and any maximums and minimums of the graph on your screen. So we can start by press zoom, there's the zoom button, and then scroll down to number 6, standard. You can scroll down to number 6 and hit enter, or you can just hit 6 and it will do zoom standard. So this is what I see. I don't see anything. That doesn't feel very good. It says next press zoom and then select standard. What do you see? I don't see a graph. And I don't see my equation. This is supposed to be a parabola. Where's my parabola? I don't see it here. Why is that? Well, if we go to Window to see the settings for the standard viewing window, I notice the standard viewing window is -10 to +10 with a scale of 1, -10 to +10 with a scale of 1. Okay, that's what the viewing window is for Zoom Standard. 10 to the left, 10 to the right, 10 up, 10 down. Now, this is part C, change the viewing window as follows. When you're done, press graph and sketch below what you see. So now I see I'm supposed to have an x min of -2. Hey, and by the way, that's not negative, that's subtraction. That's negative. If you type in -2 and hit graph, your calculator should give you, but it didn't. I'm very surprised. I thought it was going to give me an error. Oh, okay, -2. Huh, that's very weird. All right, I'll just shut up. Go to window, and now I'm typing in -2. I'm typing in +4. I've got a scale of 1 still. My y min is 10. My y max is 20. And my scale is still 1. Then it says once I've typed those in, I should press the graph button. Oh, there's my parabola. So what had happened before was that we used this viewing window, but our parabola was up here. And we couldn't see that because we were stopping at 10 and we couldn't see where the parabola was. So don't think your calculator is broken just because when you graph the function, you don't see the function. Think about changing your viewing window, okay? It says here, one of the reasons we learn to graph by hand is to make finding a good viewing window much easier, right? Because I can have this hand-drawn graph and say, oh, look, my graph of this square root passes through 15, 10, 16, 11, and 19, ooh, I don't know what that one would be, 12, that's what it would be. I'm not going to be able to see this graph on my standard viewing window, which means I'm going to need to go to window and put in some parameters, right? I'm going to need to say, hey, let's build a viewing window where I can see this. So maybe my x min could be 10, and maybe my x max, something on the other side of 19, like 20, and maybe my y min needs to be below 10, and my y max needs to be above 12. And so I might use my knowledge of by hand graphing to help me find a good viewing window in my calculator. All right, exercise 2. We've got this parabola in our calculator, and it says, let's find the vertex of the parabola that we have in y1. So I want to find that vertex. How can I do that? Well, it says, press graph. I got the graph. Then press, not the press, then press the second button under y equals, this button. So we've got the graph. Now I want to press the second button, followed by the calc button. Where's calc? It says this is above trace. So there's trace, and above it is calc. That's why I used the second button, because I wanted to get to that little yellow calc up there. So I've got second trace. And now it gives me all these options. And what are we looking for? We're looking for the vertex, which in this picture is a minimum. So I'm going to go down to 3, or I could just type in 3 and hit enter. Now it's saying here, in order to find the minimum, your calculator needs you to tell it between what numbers to look for the minimum. So first we're going to use the left arrow key to move our cursor so that it is to the left of the minimum on the graph. So there's my cursor now, but I want to move that so that it's left of this minimum point. So I'm going to the left. Now it doesn't matter how far to the left. It could be up here or here or here. I just want to make sure that I'm comfortably on the left. When I get to that place, when you are to the left of the minimum, hit the enter button. Now use the right arrow key to move the cursor to the right of the minimum. So now I'm going to come use the right arrow key and get to the other side of the minimum. When you are to the right of the minimum, press enter. Now it says guess. Finally, your calculator politely asks you if you'd like to guess. The way to say, no thank you, will you please find the number for me, is simply to press enter one last time. And then it says I'm supposed to write down the minimum value here in my lab. And so what am I writing down? I see 0.5000006, 11.5. Well, that's rounding error, and really my answer is 0.5 or 1/2, comma, 11.5. So that's what I'm writing in as the minimum value. The vertex is at 1/2, 11.5. Okay, let's take a look at exercise 3. Choosing a good viewing window. Okay, press y equals. Use the clear button to erase the equation that we typed in. Once you've done that, type in a new equation. Negative x squared plus 4x, that's the x button, minus 20. So I've typed that in. Be sure to put a negative in front of the x squared. I did. And hit, and not the subtraction symbol. Not knit the subtraction symbol. Not the subtraction symbol. Another typo in the lab. The negative sign is on the bottom row of the keyboard. Okay. Press the zoom button and choose standard. Zoom, standard. But where's the graph? The viewing window is not, the standard viewing window is not always the best viewing window. Again, I don't see my graph anywhere. So, press zoom, and now select zoom out. Okay, zoom, and look, it says zoom out. Not zoom standard, but zoom out, and hit enter. Now you can use trace to help you choose a better viewing window. Oh, don't forget, when you hit zoom out, you must also press and enter. See, so let's go back to our standard viewing window. This is where we were originally, and we don't see the graph. And now I'm saying, press the zoom button again. Hello? Oh, I paused you. Okay, zoom, standard. So there's the graph. I don't see anything. Then I say to you, do zoom out. Now, I generally don't like zoom in and zoom out because I don't feel I have as much control over it, and it leaves me to, the calculator goes and does the way it's going to zoom out, which may or may not be what I want to be looking at. So if I hit enter, I see zoomed out. I finally see nothing. Oh, that's because I didn't hit enter. Okay, so there I see. And so if I use trace, I can see where my cursor is. My cursor goes something like negative 16, negative 346. That's way off my screen, huh? But clearly these y values need to be very negative for my y min. My x is only like negative 2, but my y is negative 36. And what about my y max? Well, it looks like my maximum is around negative 16. So I think I'm going to change my viewing window so that I still go negative 10 to 10, but this time when I look at my y values, negative 40 is probably okay. I might want to push that further, negative 100 to 0 in steps of 10. Okay? So I'm changing my viewing window based on tracing, and now I have a really decent picture of this down-pointing parabola. If I do zoom standard, I don't see any parabola at all. So I can use zoom to help me figure out where is the graph, because now we're just going to zoom out. Oh, I see most of it is below the x-axis, and that can allow me to change my viewing window to be something more appropriate. I said negative 100 to 0 in steps of 10. When you think you have a good viewing window, note it below. And so this would be negative 10 to 10 in steps of 1, negative 100 to 0 in steps of 10. Is the vertex of the parabola a maximum or a minimum in this case? Well, that's my high point, so that's a maximum. In order to find the vertex of a graph, we need to press O. That's a maximum, right. In order to find that vertex, I'm going to do second trace to get calculate, second calculate, and this time I'm looking for a maximum. So the directions say press second calc, and this time choose maximum, and then enter. Now we use our left arrow key, like with finding the minimum. Your calculator needs you to tell it between what numbers to look for the maximum. So first use the left arrow key to get to the left side of the vertex. When you are to the left of the maximum, hit enter. Next, now use the right arrow key to move the cursor to the right of the maximum. When you are to the right of the maximum, hit enter. Finally, your calculator politely asks you if you'd like to guess. Just press enter one last time. And so the calculator thinks, and it comes back with the maximum. It says the maximum is located at 2, -16. 2, -16. Okay, practice time. Find a good viewing window for the following parabola by using zoom out and trace. You know you have a good viewing window when you can see the parabola, not just a smudge that looks like a vertical line. Okay, so I'm not sure what that means, but I'm sure we'll see in a moment. 50x squared minus 200x plus 208. So if I were to do zoom standard, I see a little smudge here at the top of my graph. Oh, that's adorable. But that's not a parabola. I mean, I can't really see a parabola there. So what I'm suggesting is that we hit the trace button and we get some idea of where we are. It looks like sorry, I seem to have zoomed out momentarily. Okay, I'm back at zoom standard. I don't see the graph. Do I see the graph? There we go. I see the little bit of the graph. Now it says that I'm supposed to use the zoom out option. Don't forget to hit enter to choose it and hit enter to activate it. So you have to hit enter twice there. And I see what might be a parabola here, but I'm having a really hard time seeing it. I know if I hit the trace button, I can trace along the graph and check out these y values. These y values are really big and getting bigger, so I'm going back the other way. The lowest my y value seems to get is 12. But my y values get very high after that. They go right up to the stratosphere. And it looks like my x's aren't changing a lot. So I think for my viewing window, I want something like -2 to 2. And then my y values, well, my y minimum, I could probably use 0 safely. 10 would work. And my y max, wow, those numbers were going really high. I want to say at least 1,000 in steps of 100. Let's see how good this is. Huh, look, I'm not seeing the whole parabola. So I need more x. I need to find more x. So this is not enough. Let's try moving that to something like 8 or 10. And graph. I definitely see the parabola then. You know, the problem with my y values going from 0 to 1,000 is that it's really hard for me to see that low point around 12. Like some students might see and think that this vertex is on the x-axis. So I wonder what happens if we change this to be 100. Oh, so I definitely get a better sense of not touching the x-axis there. And if I only want these y values, I don't need all this extra x. So I could bring this in 0 to 5. Well, I think that's a pretty nice picture. And so I would note down this viewing window. This viewing window is definitely not the standard viewing window. Okay, now we're supposed to find the location of the vertex here. Do you remember how to do that? We pressed second, calculate, minimum. We move our left arrow to the left of the minimum. And I have a hard time seeing it because of all this writing here, so don't be shy about going until you see the cursor. Hit enter. Now it's asking for the right bound, so I move to the right of the minimum and hit enter. Would you like to guess? No, so I hit enter again. And so I have my minimum located at 2, 8. 2, 8. All right, exercise 4, finding the zeros, aka x-intercepts of a function. In y1, type the following function. Okay, y1, I'm typing in x raised to the third power plus x raised to the second power minus 6x. Try Zoom Standard. So press Zoom, number 6. Ooh, it's a cubic function. That's right, it was x to the third. Notice this function has 2 turning points, one minimum, one maximum. Find the coordinates of these points and note them below. Okay, so if I do second, calculate, maximum, I want to move my calculator cursor to the left side of the maximum and hit enter, and then to the right side of the maximum and hit enter. Do I want to guess? No, so I hit enter again, and I can see my vertex maximum, or the maximum point on this graph, is at negative 1.786, comma, 8.209. In our class, we're always going to be rounding to 3 decimal places at the end of the problem, so don't be afraid to start that practice now. Now, we still need to find this minimum, so I'm going to go back to second, calculate, and choose minimum now, and move my cursor closer to the left side of that minimum. I'm going to hit enter. I'm going to move my cursor to the right side of that minimum and hit enter. Do I want to guess? No, so I'll hit enter again. And I see 1.1, I see 1.190. That's what I would have, right? 1.12, because this is going to round up to 2.0. And then the y value appears to be negative 4.060. I guess that would be 1 if I rounded. So there's the ordered pair for my minimum. How many times does the graph cross the x-axis? Each of these x-intercepts, 1, 2, 3, each of these x-intercepts is a 0 of the graph. You can estimate by looking at the graph, but we can also calculate them with our calculator. So how do we do this? Part C says press second, calculate, and this time choose 0. enter. Don't forget to hit enter after you do 0. Use the left and right arrow keys to find the lower bound and upper bound and guess just like you did when you were looking for minimums and maximums before pressing enter. Okay, so I've got a question here. What's the left bound? I want to find this x-intercept, and so I want to be to the left of that point. Well, is to the left of that point on this part of the graph or this part of the graph? To the left is going to be this part of the graph. So I want to move my cursor until I'm to the left of that first x-intercept. There it is, and hit enter. Now, where's the right side of the x-intercept? Well, that's going to be up here. So let's move to the right and hit enter. Do I want to guess? No, thank you. Hit enter. And I get -3, 0, -3, 0 as one of my x-intercepts. Okay, what about my next x-intercept? Well, that one kind of looks like it's at x equals 0, but let's confirm it by doing second calculate 0. I move my cursor to the left of that middle x-intercept and hit enter. I go further and I move to the right of that x-intercept, which has me this time below the x-axis, and hit enter. Do I want to guess? No. And yep, 0, 0 is that ordered pair, just like it seemed on the graph. But sometimes it may seem like that's where the x-intercept is, but if I zoomed really far in, I'd find it was some decimal place really close to, but not actually 0, 0. So I like confirming these intercepts. Second, calculate 0. Now to find this third x-intercept, enter, move to the right, enter, and no, I don't want to guess. And I end up with +2, 0. So those are the intercepts that you should be able to find. Okay, exercise 5, finding function values. What does it say? Enter the function y equals x to the third plus, hey, did you know about this? Second insert allows me to insert something there. Second insert. So I've got plus 10x squared minus 211x minus 220. Okay. And then it says, find a good viewing window that allows you to see this picture. Okay, so if I start with Zoom Standard, that picture doesn't look like that picture. So I need to, get a better viewing window. I don't see anything here or here, which makes me think that my y min and my y max are way off. So what if I do -100 to +100 in steps of 10? Will that help? Wow, that didn't really help. Huh. So let's think about going back to Zoom Standard, and then instead maybe we try Zoom Out like we did earlier. Remember, you hit enter to select it, but then you have to hit enter a second time to make it work. Ooh, I see more parts of the graph. Well, that's great, but I still don't see this maximum and this minimum. So I think I need to zoom out again. Huh, I don't see it. But what I see here is I have a lot of X that I'm not using. So I'm going to go over to my window, and I'm going to make these X's be something like -10 to 10 again, and see what I see. Huh, I lost my other two x-intercepts. So I need to move maybe negative 20 to 20 in steps of 4. Well, I feel like I'm getting closer. This one looks like it's at negative 20, and 20 is here, so I'm just past 10 here. So I think these are good for the x's, but I need my y's to be a lot higher. So I'm going to go to my window, and I'm going to add a 0 to each of these. And my scale, I think I'm going to plug in 200. Oh, so close. So I think my y min is enough, but I want to push my y max higher. So my y max, how about 2000? Graph. Hey, I think I've got a decent viewing window now. I might want to push it a little more to the left because this picture over here shows some stuff going below the x-axis. So maybe negative 30 would be better. Okay, so I think I went through the process of finding a good viewing window. I zoomed out, I thought I could use trace, I can change my window settings based on where I think things are. It's a process you're gonna have to engage with. And the more you engage with and not hide from it, the more when you need this tool, you'll have this tool at your hand. So let's find the 3 zeros. Do you remember how to do that? Second, calculate 0. Move your cursor to the left of the first x-intercept. And I can follow along here to see where I am. If I lose track, I'm looking to be down here, not up here. So I want to keep going and hit enter. Move to the right and hit enter. Do I want to guess? No. I hit enter. And I end up with negative 20, 0. So my first 0 is at negative 20. What about that second 0? It kind of looks like it's at 0, but not really. Second, calculate 0. Bring my cursor close to that x-intercept. Hit enter. Bring my cursor past this x-intercept. Hit enter. And guess, no, so I hit enter. And this time I get negative 1. And then finally, there's this last x-intercept, this last 0 over here. Second, calculate 0. I'm going to bring my cursor close to it and hit enter. And I'm going to go past and hit enter. And I don't want to guess. And I get positive 11. Positive 11, 0. Okay, now let's find function values. What's the function equal to for each of the following x values? When x equals 0, when x equals 12.21, and when x equals 3/4. First would be easy enough without a calculator, just by plugging in a 0 for all the x's. I'm plugging in a 0 for all these x's of the original function. This goes away, this goes away, this goes away, and I'm left with negative 220. So that's pretty easy to do to get negative 220. But plugging in the other x values would be terrible. So let's use the calculator's table feature to help us do this. You only need to do this next step once ever. Okay, this next step you only ever do once. Press second window, and that's table set. When you press it, yours probably says auto. Notice I've changed this auto to ask. And the way you do that is you down arrow on to ask. For independent variable, choose ask and press enter. So your highlighting should be ask on the independent variable and auto on the dependent variable. You really need to set your calculator like that. It doesn't come from the factory that way. Okay, then press second quit. Second quit to back out, to exit back to the main screen. You should never have to do that step again. Next, press second graph. Second graph. Ooh, look, a table. In the column with the X at the top, you can type in values like 12.21 and 3/4. When you type these in, you should see values showing up in the Y column. Write these values here as ordered pairs. So I see 514.85 and 3/4 negative 372.2. Hey, a word about these numbers. It kind of looks like they're decimally, and do they really stop after 2 decimal places or after 1 decimal place? Well, let's use our arrows to go over there and up. Whoa! Negative 372.203125. Oh, if we're rounding to 3 places, I need 03 here. And what about the one above it? Whoa, 514.8478, so 849. Oh, and that's why the calculator rounded it to 5. So please write down your decimals to 3 decimal places, and you can always check that by going on to that value and reading what it actually says it is. Now, what if we wanted to find out when, what x value, the graph had a certain y value? I'd like to know when this graph has a y value of 1,000. Sadly, I can't type in 1,000 in the y column of the table. I only use the table when I want to evaluate the function, when I want to plug in x values and find out what the y value is. Here, I know the y value, and I'm trying to find the x's. I can't do that with my table. We have to do this another way. Instead of using the table, we want to know an input value for a given output. We'll use the graph. So, press y equals. You've got the original polynomial in y1. In y2, clear anything that might be there, and then type in 1,000. 1,000. So now I have the polynomial and the horizontal line 1,000. Now press graph. Oh, look, there's the line y equals 1,000. You should see our graph above the horizontal line at y equals 1,000. Now, second calc, but we're not going to do 0, we're not going to do maximum, we're not going to do minimum. This time choose intersect, second calc intersect, and hit enter. When you now use the left arrow key to move your cursor close to the furthest left x-intercept. Okay, so I'm moving away from that second point of intersection, closer to this first point of intersection. It doesn't matter if I'm below or above. I'm just trying to be near that point of intersection. And it says, is this the first curve? Sure, the polynomial is the first curve. Hit enter. Is this the second curve? Look, it jumped to the horizontal line. Yes, that is the second curve. Do you want to guess? No, not really. So hit enter again. And I see here the point of intersection is located at negative 17.965, comma 1,000. Huh, that's not the no. Oh, that's 100. I need to change that. Okay. Now use this method second calculate intersect to find each of the other points of intersection. So I'm going to do second calculate intersect. I'm going to look for that point of intersection now. So I want to bring my cursor close to that point of intersection. If I don't do this, it's going to find that point again. And I don't want to find it twice. I want to move on and find this one. Is this the first curve? Sure. Then it jumps to the horizontal line. Is this the second curve? Yep. Do you want to guess? Nope. And so I end up with a second point of intersection, negative 5.170, comma 1000. And now I'm going to find that third point by repeating the process. Second, calculate, intersect. I'm going to bring my cursor close to that third point of intersect. Whee! And then back up again. Hit enter. Is this the second curve? Yes, it's the straight line. Hit enter. Do I want to guess? No. So you hit enter. And I end up with the ordered pair 13.135, comma 1000. Okay, so you should be able to find the intersection of 2 points on the graph, 2 lines on the graph. Pull it all together, practice time. Max, the human cannonball, is shot out of a cannon, the end of which is 10 feet above the ground at a velocity of 50 feet per second, at an angle of 45 degrees. Max's flight path can be modeled by this equation, where y is Max's height above the ground in feet, and x is the horizontal distance from in feet from the cannon. Find the good viewing window, note it down, and sketch the graph below. So I'm going to type in y1. I'm going to get rid of that thing in y2. In y1, I'm going to put in my new equation, negative 0.0128x squared plus x plus 10. If I start with zoom standard, it looks like a straight line. But I know this is a negative x squared. It's supposed to be a down-pointing parabola. So the maximum is somewhere over here, and I feel like I should be pulling the screen this way. So let's change these y values to 100 in steps of 10. See what happens there. Do we see our parabola? Whoa, I see a parabola. No, it still kind of looks like a line, but it looks like the vertex is going to be way over here. So I feel like I've got too much y and not enough x. So let's change that on our viewing window. I need more x. So how about 50? Well, that's better, except I don't see the max and I don't see the other x-intercept for this down-pointing parabola. I think I need to go even further that way. Okay, so let's change 50 to 100 in steps of 10. Not 10, but 100. Nice. I feel like the x's are pretty good now, but I'm missing this high point, so I need to change my y max and make it a little higher. How about 30? I see the max now. I also feel like this is a little tight. Like if I had to find that x-intercept, I'd probably want to push the x's to the left a little bit. So I'm going to take my x-min and turn it into negative 20, so I have a little more space over there. Ooh, I feel like that's a pretty good picture. And so our viewing window, or mine, yours may vary, negative 20 to 100 in steps of 10, negative 10 to 30 in steps of 10. How high will Max be when he's 20 feet above the ground? Well, this is height, and we know the height is 20. Think about what we've learned in the lab and use one of the techniques to answer the question. Is this where I'm supposed to use the table feature? Is this an input or an output? Well, this is his height, and up here it tells us his height above the ground is our y value. So when I'm given a y value, I can't use the table, I have to use the graph. So I type in 20 into y2. Max is 20 feet in the air here and here. How high will Max be when he's 20 feet? Oh, Max will be 20 feet above the ground when he is 20 feet above the ground. So I don't want how high will he be, how far from the cannon will Max be when he is 20 feet above the ground? So that means I'm looking for x values. Okay, how far from the cannon when he is 20 feet above the ground? Second, calculate, intersect, bring your cursor close to that point of intersection, hit enter, enter, enter. Max will be 11.774 feet from the cannon the first time he gets to 20, but second, calculate, intersect, the second time, so I have to bring that cursor close to the other point of intersection by using this arrow key, and then hit enter, enter, enter. And this time I find 66.35 feet. Okay, those are the two times when Max is 20 feet above the ground, and I had to graph 20 and do second, calculate, intersect. Will Max clear the 10-foot flames that are 75 feet from the cannon? So 75 feet from the cannon, maybe that's here, maybe that's here, maybe that's here. There are 10-foot flames. And we want to know if Max gets over them. Well, here, Max gets over the 10-foot flames because his height would be above 10. But here, it looks like no, Max is going to be burned to a crisp. And here, Max has already hit the ground before this. So I'm trying to find out where Max is when we're 75 feet from the cannon. Feet from the cannon is our x value. So I'm going to go over to my table, second graph for table, and I'm going to type in 75. When he's 75 feet away from the cannon, what's his height? His height is 13 feet. Max is 13 feet. Max is 13 feet. So this is 13 when he's at 75. He will miss the 10-foot flames by just 3 feet. Ooh, that's going to be tight. So how did we do that? We used the table feature. I used the table feature here because I was given an input and I needed to find the output. But in part B, I was given the output and I was looking for the input that makes that. I can't use the table when I'm given a y value. I have to graph this y value and do second, calculate, intersect. Okay, part D, what will Max's maximum height be? So I'm here looking at my graph and I want second, calculate, maximum. I want to move my cursor to the left side of the maximum. I can check that out by seeing if these numbers are going up or down. They're going down, so I'm going to hit enter. I move my cursor now to the right side of the x-intercepts. The numbers go up, and then they start coming back down. I hit enter. Do I want to guess? No, so I hit enter again. And I see the maximum height is 29.531 feet. And when does this occur? This occurs when he is 39.062 feet from the cannon. How far from the cannon will Max land, i.e. height is 0? I'm looking for this. Well, that's an intercept, or a 0 of the function. So I'm going to do second calculate 0. I want to move my cursor to the left side of this x-intercept. So somewhere over here. There it is, getting closer. And hit enter. And then I need to go to the right side of this x-intercept, which is down here. So I'm going to keep going. Once I get below the x-axis, I can hit enter. Do you want to guess? No, I do not want to guess. And so my 0 is located at 87.095 feet. Max will be 87.09 feet, 095 feet away from the cannon when he hits the ground. If the net in which Max wants to land in is 8 feet high, what x value would you tell the safety team to place it so that Max will land safely? So is this 8 feet high an x value or a y value? Well, this is not an x value. It's how high he is. It's a y value. And what did we do up here when we were given a y value before? We have to graph this line and do second calculate intercept. So let's put in the line y equals 8 and graph. Now I notice that there are two places where Max intersects the line y equals 8. This is the first one. It looks like before Max is fired from the cannon. It's a negative distance, so we don't want this one. Max goes up, he hits his maximum, he comes back down into the safety net. This is the x value. We want to know the x value here to tell the safety team where to put the safety net. So let's do second, calculate, intersect this time, and bring our cursor close to the point of intersection. And hit enter once, twice, thrice. And I see the safety team should place the net 80.076 feet from the cannon. Label your graph with points that you found. Okay, so here's my graph. I found this point here, the maximum, to be 39.062, comma, 29.531. We know the safety net is going to be at 8 feet high, and the x value there was 80.076, comma 8. We knew this point here when he wanted to be above the 10-foot flames. That happened at 10-foot flames when he was 75 feet from the cannon, and he was 13 feet in the air. And you might want to put in this y-intercept as well, since that's easy to read off the graph, 0, 10. So there's my well-labeled graph for part G. I hope this was helpful. I recommend that you go through and do the lab again on your own. Maybe print out a clean copy. But you will find the year is much happier if you know how to graph, if you know how to find a good viewing window, if you know how to find maximums and minimums and points of intersection and x-intercepts, also called zeros, as well as being able to use the table feature when you're given an input and graph when you're given an output. There's a lot of stuff here, so I might think about practicing it again on your own. Okay, There is a homework assignment here, calculator use worksheet. So this worksheet will have you practicing the things we just reviewed in this video, okay? You can find both the in-class lab packet as well as the homework in our Office 365 team folder under Assignments, Files, Graphing Basics. Let me know if you need any help. Take care.